Hey everyone, happy Sunday. Hope you had a great weekend. Meteorologist Zach Gilday watching Saturday really close. And so wanted to kind of give you a little bit of a breakdown on this past Saturday and what happened in Tennessee. And obviously it struck home for you big
Sure, it
time.
sure did, Dan. Yeah, my brother, my sister-in-law, they live in Nashville, or they live right outside Nashville in Hendersonville, and one of the deadly tornadoes passed right through Hendersonville.
I mean, Hendersonville, that's where the tornado was, northeast of Nashville.
Yeah, my
And
brother he was at work in Nashville. I was on the phone with my sister-in-law like during the events. I called her. I was like, "Get to your safe place right now. Get in that bathroom." And my niece was there too, and so like they were all huddled up in the
all hunkered
bathroom,
down. I mean, that's
and it missed them by it must have been a quarter mile, half mile.
to their north, right? So the
Yeah,
tornado was to the north of them, or were they north of the tornado?
they were south of the
They
path.
were south of the path, yeah, and so they missed them.
Yeah,
But the tornado north of them. So, I mean, just real ominous, real scary. What's interesting too is that system when it came in here, we were watching it. We knew something was going to brew with that system.
yeah,
It was really kind of tricky all along. So we're going to kind of dive into the science behind it because Zach and I took a detailed look at this earlier today. Wanted to share some information with you so you can kind of know, what are some things that you look for severe weather and tornado potential. And sometimes it's the small details that make the big difference, Zach.
yeah. And
Um,
that's kind of what happened.
that is exactly what happened. And why didn't it happen here? We'll look at that as well. First of all, our weather's pretty quiet this week, so you don't have much going on. So
Pretty good.
if you're just tuning in, stick around. You'll probably learn a few things about severe weather. So let's get to it. And first of all, look at the water vapor. Now, you might remember about a week ago, we were looking at this system. Zach, you were on Sunday. Actually, I was on Sunday. You were off last Sunday
Yeah,
because I had to go to that seminar last week. Was really busy,
I
but I
was
was
on
at
Saturday and I left you a note saying
yeah,
maybe storms. I was thinking Saturday and I was thinking maybe snow Sunday,
yeah.
and then sure did that change.
Snow Sunday, it was totally clear. But here's the reason that this all cleared. So one of the things we use as meteorologists is water vapor. Water vapor is a very good indication at which way the air is moving. So we are going to go on the other side of the globe and spin all the way around. And so now we're going to look just off of Asia. You can see Tokyo, you can see Seoul. Our system that's coming in that brought the tornadoes is this right here, this little shortwave. And we're going to follow it. So, first of all, I got to go back in time to when it first started. And so this is the system right here that brought those tornadoes. Watch, we're gonna follow it and we're gonna backtrack. So first of all, it's right here, this little dip in the jet stream. It's not this big system. It's not this big system. It's this little tiny guy. And everything is like a chain reaction to what storms end up doing, and this is what models are trying to predict 7, 8, 9 days out. It's absolutely unheard of that someone would put this is exactly what's going to happen with the forecast because
Yeah,
there's so much uncertainty. So watch this. We're going to put this into motion and you're going to see right here this little wave right here. It's not this.
kind of hard to even see.
It is hard to see. And that's the point of all this. It's super hard to see. And it's even hard when it gets to the Aleutian Islands. So there it is. We're still tracking it. It's right here. Now, what I'm going to do is I'm going to slowly pan it over so you can keep track. Again, we're located right here. We're looking at this little wave. Watch what happens as it swings in. Still doesn't show up. Now, there's two different satellites here. That's why you're seeing the split in the water vapor. So it's combining a global. You have goes west. You have the Himawari 8, which is the satellite that's basically looking at this. And here's that little shortwave. Now, it's this right here. So let me go back in time just a little bit and we'll track that again. So here we go. There's the dip. There's a little energy. Now it's this right here that's going to start the tornado potential for Saturday. I mean, it's hard to believe, but it's this tiny little thing. So now this is Wednesday. And Wednesday, it's still well off the coast. So now we got to pan a little bit more.
And I think Wednesday is the day where we took the snow out.
Yep. We took the snow out completely. And the reason for that is because the system was going a lot faster. you could tell the system was going faster and the models knew it. Now, do you see that this little white arc right here by the Aleutian Islands, just to the south of Alaska? Now this system is starting to dig. And so you can see that little bit of, you see that little white, Zach?
Yeah.
So that's the system coming in right there. That is the system. It's not this, it's not this, it's this. Now watch what happens over time. That starts diving in. And when that dives in, now watch. Now it's organizing. Well, here it is Thursday. We had our severe weather potential on Friday, but we know that didn't materialize, and we'll take a deeper look at that in just a little bit. But there's a look at the system diving in. Remember, it's just west of Portland. Here it is diving in. Now, the severe weather that came here is this wave, or at least the potential is this wave right here. This brought our severe storm potential, but then it was out of there. So now we're going to step forward in time. Now look at what's happening west of Denver. All this energy is lagging back. It's about to fling in. We'll take a look at radar too, and I'm going to show you some other stuff. Now you can actually see the jet streak that's occurring. It's starting to wrap around the base of the trough. A couple of things, Zach, that I was pointing out to you earlier, and I want to point out to you if you're forecasting severe weather. You can see rising motion down here because these are streaked clouds, okay? So essentially like cirrus streaks. That shows you got some upper level energy. And by the way, the model's terrible at this. They did not handle it. See how that started to streak right there? Here's the system diving in. This is what brought the tornado potential in Tennessee. Now watch what happens as that rounds the base of the trough. You can actually see it moving through. And here it is, rounding the base of the trough. Remember, there were storms that afternoon or that morning in Arkansas, but they really didn't do much. And that's because the energy didn't fling in. And now watch, here it comes. It's right about here. It's right at the nose of that dry punch. And then at that point, there's already storms and severe weather. So you can actually see, look at the rising motion as that system flung around the base of the trough. Pretty incredible. So let's backtrack again. And let's make sure that that was actually the energy that flung in. So here we go. It's right here. All this. It's just moving on shore Friday early morning. We'll step back. We'll go back up here. So here it is, this little wave that's by the Aleutian Islands. We'll go back here. I mean, that's pretty incredible that the models actually have any semblance of what's going to happen when a lot of these systems haven't even formed yet. So now we're going to go back to here. Remember Korea and all that stuff. And so there we go. I mean, you don't even see it. It's so fast. There's so much that happens in this point that it's like, where did he even get that storm? But it's basically right here. This is the start of the trough right here. Unbelievable, huh?
Yeah,
All right.
and I'm sure the data sampling for the model is probably not too good up there.
No, not good at all. And this is all chain reaction stuff. So one more time. And now we're going to zoom in on Northwest Arkansas. So there's the trough. There's it starting to dig around. You can see the energy flinging in. There's more energy that's happening down by Baja that ripped in, that caused those storms. You can actually see the streaking of the clouds. Those clouds that are by South Texas, that is energy. That's a very good sign that you have energy moving in. So let's look at a different water vapor. Now, this is a little bit closer in, and this is for the Northwest Arkansas area and the River Valley. So first of all, why did the storms not take off? Why weren't they as severe as expected? Well, there's a couple things, Zach. Number one is the moisture return. And remember, this is a lot easier. Let me just stress this. This is a lot easier to do after it's already happened because it's called armchair quarterbacking. So while we're armchair quarter, we're looking at what happened in the past and we're trying to learn from it. We're trying to understand better so we might be able to see some of these features and some of these signs and maybe be like, okay, we're a few hours imminent from tornado potential here. So we'll go back to this now. Here's the water vapor. And what we were really watching was this energy swinging in. So right here, if we look at water vapor, This little streak right here is what formed the storms as it came through.
Now the models did pick that up the day before.
They did. They did. Well, the HRRR didn't have any storms for us, though.
No. I'm saying like the European vorticity showed some energy coming in,
But it didn't develop.
but the short range models did not show storms.
They did not show storms.
So we knew that energy was going to come in.
Yeah. We knew the energy was going to come in, but there was a question as to whether there would be storms. So it's like, was it going to be capped? Was there going to be too strong of 850, warm air advection, which essentially is your cap? But this right here is the little wave. So that little dark spot, and you're going to see some storms that try to pop up right there, right on the nose of that in southwest Missouri. Well, those storms didn't do anything. Now, see how that little wave comes overhead, and as soon as it does, there's the storm development. Now, there's two things with this storm development. Number one, it was oriented from northeast to southwest, and our shear vector was basically west to east. So at the 0 to 3 kilometer bulk shear was not favorable for this. I thought the line would be more north-south, didn't you?
Yeah.
That's what the model showed.
Yeah.
That's not what happened. So that's why when we were saying tornado potential is going to be greater, and it didn't materialize, that's one of the reasons. Number two, the shear in the 0 to 3 kilometer backed. So instead of it going, veering is from southwest to west, this went west to southwest. So if you have a line that's flowing southwest to northeast, and you have the back shear that's southwest, that's parallel to the storm system.
Yep.
And that's not favorable for tornadoes. Now, you'll notice too, after this comes through, guess what? There is sinking air because this wave has already moved out. This energy hasn't arrived yet because it's lagging back because it was a positively tilted trough. And now you're going to see as that comes through, it just kind of dies out, doesn't it?
Yeah.
So the storms are basically having to fight sinking air,
So that brown behind
upper level convergence.
the
Yep.
central Arkansas, the blue area, the brown behind it is sinking air, drier air.
Yeah. And warming too.
Yeah, and warm.
These are warm. That's what water vapor is essentially measuring, is the temperature. And that's warmer air. Now, when we work our way to the southwest, here comes those streaks. Now we can see them a little bit better on a more detailed water vapor. See those streaks, clouds? And then you're going to see this right here. This is more enhanced lift. Now, when that streakiness in the water vapor makes its way east, you're going to see it fire off storms in Mississippi. That is the beginning of the energy when those cells were pretty impressive in Tennessee. So there you see that. Now,
just east of Memphis, has some tornado warnings.
tornado warnings. Yeah,
Just
that's
east
right.
of Memphis.
Just east of Memphis. And there's the trough swinging in. And look at all that rising motion. Now, we're going to go to this. This is a little bit more of a zoomed in view. And you're going to see that short wave coming through right there. And the energy was more focused, which is what a lot of people were saying. They were thinking the energy would be farther north, but it was far enough south. When we look to the south, there's those streaks in the clouds, and then there's the storms that fired up as that energy moved in. Now, another way you can look at that is with infrared. Infrared will let us see essentially colder cloud tops. Colder cloud tops mean you have rising motion. So you're going to see 8:30 in the morning, there's that little wave. That's one wave that came through. Remember, we were expecting some cloud cover? Well, once that wave went through, guess what? It cleared out. That's because there's sinking air.
Yep.
Sinking air subsidence on the backside. Now, as we step through in time, there's that rising motion, and then you can see those cloud tops. But those aren't super cold. Those are somewhat cold. And there was one storm that was rotating a little bit more. Remember that one by Scott County?
The one just south of Scott County?
Yeah, the one
Yeah.
just south of Scott County. And you can actually see right there a
Yeah.
little bit of stronger thunderstorm development. How can you? There's the colder cloud tops. That's the darker colors in the infrared. Now, I'm going to get back out here, zoom out a little bit, because you're going to see what happens in Texas. You get this little bit of streakiness right there, west of Dallas. It's very subtle, but that's energy that's swinging in. And of course, it's fighting all that dry air, and so it doesn't really hold together. But after that system came through, look at how once that wave of energy moved in with all the other ingredients, boom, you had an explosion of thunderstorms. And Zach, I was showing you this earlier too. So how many lives were lost, Roby? We had six people, at least six killed, from what I heard. Right, 4 children, 2 adults.
I forget the exact.
Is that right?
Demographic.
Yeah,
But
but I know there are 2 children, 1 adult in one of the homes.
yeah, I think that was in Clarksville.
Yeah,
I think.
and we're going to go through that on the radar here in just a bit. So there's your answer there. But what I want to do here is I want to show you something that sometimes can preclude tornado development. And Dr. Ted Fujita, the doctor of tornado research, who is absolutely amazing. He's passed on now, but he's the one that initially made the F scale, the Fujita scale. That's the origination of the Fujita scale. I'm going to show you here some colder cloud tops, and you can see how those storms are definitely stronger. So one of the ways to see stronger thunderstorm potential is to look at infrared. Infrared will help you see more than what the radar will show.
Oh yeah.
Because sometimes radar will look like just all strong storms.
Yeah.
But it's these colder cloud tops that have better tornado potential. Now, another thing that's interesting too, we're going to zoom in northwest of Nashville. And this is the system that came through Clarksville. So you're going to see at the point, now remember, this isn't exactly over where the storm is because there's a thing called parallax with the radar, because the radar isn't perfectly directly over this location. It's way farther south. And if it's looking north and the storm is higher up, it's going to appear that it's north of its location. It's called parallax. There's no way to fix it. But there's a look at the parallax. So it looks like that overshooting top is over Hopkinsville, but instead it's actually over Clarksville. So if we kind of tilt it down, there's an idea of what you're looking at. Now watch these cloud tops warm, Zach. So we were mentioning that. What do you think that is? If the cloud tops warm, that's cold. But what happens when they warm? That is
you have an overshooting top, and then it sinks.
It collapses.
Substance.
Yeah.
A little bit of substance.
So the collapse of the overshooting top, what that does is that provides what some people believe is the rear flank downdraft. The rear flank downdraft is what allows the tornado to wrap up and touch down eventually. But there's a look at that warming. You can see how that storm's bigger, and then it warms, and then it dies. And then here's another one, the Clarksville. So that was actually already past the storm. Now we're going to move a little bit east. And what time was that Nashville tornado? Just north of Nashville.
4:50.
Yeah. And so you're going to see there's the colder cloud top with that storm. Then it kind of collapses just a little bit, not much, not as much, but there's definitely a little bit of warming there. And then the storm kind of moves on. So a lot of interesting stuff there with the infrared that you can see that you normally can't see with radar. Now, when we look at this, I'll show you on the satellite radar. This is the composite radar if you want to see how many tornadoes there were. And another thing I want to make you guys aware of is these white polygons. You might see these when we're doing severe weather and tornado coverage. So what that is, and if I go back to the watch warning label, you're going to see that this is called an observed tornado. And not only observed, but it's considerable. So if you look at the polygon up at the top, again, this is all archive data. This is from Saturday at about noon, our time. Considerable tornado, 1 inch in diameter, observed, okay? And the considerable means it's most likely a strong tornado. So if we move along in time, and you look at this, and this doesn't look like a super impressive supercell, right? It doesn't to me. But these are one of those low shear or high shear, low cape environments.
Did it start as a QLCS?
Yeah, I think it did. If we look, and it kind of started as cells. Let's go back a little bit more in time. We can see exactly. I'll take it to 10 a.m. Oops. Let's take it back to 10 a.m. So, Yeah, it started off as kind of cells. And see, these are the cells that can be long track. Yeah, that's definitely a supercell. There's no doubt about that.
Oh,
That
yeah.
is a supercell that's way out ahead of the line. And the models were kind of showing more of a linear convective mode, which, sometimes people write off and say, not going to tornado because it's linear. It'll be linear. Well, sometimes it's not as exactly what the models show. There's another supercell right down there by Milan, Tennessee, just to the southeast of Dyers. You see that? Dyersburg.
Yeah.
So, but let's go back to the Clarksville one. So now it's moving through. It becomes a strong tornado. There's a confirmed. So you can see the black means that this is a radar observed tornado. And that black means that it's on the ground. So it's a confirmed tornado. Get the rest of these watches and warnings off of here. And then we'll look at the detailed radar just to show you a little bit more. So there's the tornado touching down. There it becomes observed. And then it's a strong tornado. And then it continues northeast. And then it pretty much tracks all the way through. I think
But Bowling Green,
yeah,
that's such a long track.
that is a super long track.
How many miles do you think that is?
Well, let's see. We can find out.
70?
Oh, it's more than that.
100? Oh, yeah. Yeah, that's like a lot longer.
Let's see. So it's observed right here. And then who knows? It may have weakened at this point and lifted, but let's say it didn't. Let's say it goes through Bowling Green. It still had a tornado warning. My goodness, that was a long track. So
Yeah,
if we
look at
go
that.
here and draw it, let's see.
100 miles.
Yeah, 100 miles. Potentially. Now, I think there was a break in the track.
I'm sure it lifted and
Yeah.
then strengthened.
Yeah. All right, let's get to the radar. Let's get to the mega Doppler source. So we're going to look at, we downloaded the high resolution archive radar data, and a couple things to note with this. First of all, does anybody have any questions? Yeah, Tiffany, absolutely heartbreaking for those that had tornadoes. This is why we're kind of doing this, looking back, trying to understand what can we predict better, like what are ways that we know, hey, this is for sure going to happen, like some of the signs in the upper levels and the energy in the upper levels. So we're going to go back here to Dover. Now I'm going to do a split screen on this, and we'll do one with velocity and one with reflectivity. And we'll set the storm motion from the warning. See how that changed the warning icon? I'm going to take our camera off the screen so everybody can get a good view at the radar. Now, remember, this is archive radar. You can see at the top. This is from yesterday afternoon, and this is just a little after 1 o'clock in the afternoon. And so now here's the storm that starts. You see this start to rotate on the leading edge. No tornado warning yet, but there it is, issued shortly after. Now we've got at the tail end of a line, you've got this area of circulation, and this is what eventually develops the Clarksville tornado. So now it's really starting to wrap up. And at this point, we already have a tornado on the ground. And you can kind of see the way that red and green is right next to each other. We'll move along in time. Let's see if there's any type of debris signature.
Ooh.
Absolutely there is.
Go back to that velocity scan. It looks tight. Doesn't look.
Right there?
Yeah.
Looks tight, but it doesn't look like
very-
it would be on the ground, does
Doesn't
it?
look very strong.
Now, the only thing is this is 1,300 feet off the ground.
So there's some contamination.
There could be.
It looks like there is like the range folding going on.
Yeah, there's a bunch of stuff going on. The range folding with the purple. Now, I was going to show you that PTDS product. Boy, is that good. Look at how it just singles everything out. So you can see exactly where that potential tornado is touching down. And look, it's already confirmed at this point. And I think the next image was a confirmed. So
Because it's all that CC drop.
yeah, they see the CC drop, which is the correlation coefficient. Debris on the road. Debris signature was noted on radar. And so there's the confirmed. There it is going through Oakwood. At this point, it kind of lifts. Now, how do we know it lifts? Well, that's because the PTDS is not on there anymore. And you can see the circulation has dropped off. But the problem is that if we're on the air at this point and we're covering this and it looks like it drops off, if we drop off, watch what happens again shortly after. This storm cycles. So now we've got a sign that it's regenerating because you've got all these bright colors that are racing away from the radar into the storm. So that's your inflow. Here's the RFD, the rear flank downdraft, and watch it start tightening up again. You can see that tightening up. So even though this doesn't look like much, it is. And then there it is again. Boom, pops up on the screen really fast. So from this to this, that happened pretty fast. I would venture to say that's almost a tornado already on the ground. I bet you the next image we see, we're going to see a CC drop. Yep.
Yeah.
So there it is. There's the circulation. Spectrum width is going to have it pegged right in there. We look at echo tops. Obviously, it's really close to the radar, so that's not helpful. Base velocity, you can kind of see it, but it's best to have the storm motion.
So at a distance from this to the radar, would you want to go up in the elevation of the height or no?
No,
Just
no.
because it's not that close.
It's not that close. You want to be as low as you possibly can.
Yeah.
So there's the circulation. Notice too, it's on the 0 isodop as well. And that's just where the wind is going perpendicular to the radar. Because if you're looking here, you're getting so you're having an east southeasterly wind essentially ahead of this storm. And how can you tell that? Well, because this is the shear. It goes east southeast. As you get farther away, it's southeast and northwest. So you have a veering of the wind profile. You see that? And then here it's almost straight south. That's literally how strong your shear is. You know what I mean? Like here, I'll draw it. If we look at the 0 isodop. All right, so, and this is how you can tell those shearing profiles. So first of all, remember, green is rain that's moving towards the radar, and red's moving away, and I guess it's not going to let me draw on that. Bummer. Thought it would. Are we already done with the game? Yeah. Okay. Well, anyways, it's not going to let me draw on that. So let's go back to here. But basically, it would be. Oh wait, it should. If I do maybe a telestration, let's see. There we go. Okay. So we have wind that's flowing. Oh, I know why it's not doing that, because it's over there. So there's the wind flowing that way. Then you have the wind moving more easterly, so it's southeast, and now you can see how farther away it's to the south. You see that? Look at that veering that's happening with the wind profile. Okay, so clear that off the screen. Let's go back into this. So there's your circulation. And now at this point, it's getting pretty serious. You've got a very impressive hook. You've got on the tail end of the hook, you have this right here. Now, another thing that we were looking at too is if you're ever looking at GR2 Analyst and you look at this de-alias settings, I would suggest not having unresolved to no data. And I'll show you why it's not good to have that checked, in my opinion. We'll see. Now, the de-aliasing is important because if you don't have that, you're going to look like you're having a bunch of outbound velocities in all locations. So you want to de-alias that. So basically, it takes care of that range folding. And it does a pretty good job of that. But there's your circulation. Look at that. That's a debris signature. See that dark black? And if we look at this on the PTDS, there it is. So this tornado passed through on the north side of Clarksville. This is north of New Providence, and that's exactly where the tornado went through, or pretty close to it. Now, there's usually a little bit of a difference where the tornado was and the beam is pretty low, but there is a tilt to the storm. So if we look at this and we look at the tilt to the storm, bring up weather 1 if you can on that one. Is the game over?
We got another minute,
Okay.
and then
You guys are getting fired up here.
Well,
All right. Let me go here, minimize this, minimize this, minimize this. Let's go here. Put on lit volume. Okay. ISO surface, go back to here, and you want to see there's going to be a tilt to the storm, a pretty tremendous tilt too. So if you look at that tilt of the updraft. That shows you the low level shear. Very, very strong with this storm. And if we look at the normalized rotation, you can really see that. We go back here. Oh, there's your tornado right there. Very evident, very clear. See the tilt? This is looking due west, and there is a tilt to that updraft, basically from the northeast to the southwest. So if we go back to this image, you might think the tornado is right here, but in fact, it might be just a little bit south. So that's a good reminder. But this is pretty close because you're only 600 feet away from the radar at that point. And then the circulation kind of drops off a little bit, but not completely. Then it cranks back up again. And so we clearly have a problem there. And then it moves through, and then it still is a tornado on the ground, a continuous 13.2 mile track. They did rate it EF3. And what was also interesting too is when it gets farther northeast, you're going to see that that PTDS shows up again right there. And this is where it's getting serious. Now, the beam is only 381 feet. That's a very impressive couplet for that close to the radar. And then you look at the normalized rotation and you got red on there. That is pretty impressive. And then finally, the PTDS, that shows it as well. And if we look at the TDEF, the tornado definitive product, this will kind of tell you what scale this tornado was expected to be. And where was it red? We saw it red. Where was that?
It was back further.
Was it back further? Let's see here. Let's go back a little further. There it is.
Right there.
Yeah. So this actually defines the strength of the tornado by using what's called the user-defined product. So what it's doing is it's taking this CC and it's measuring how high up in the air that CC drop is, the correlation coefficient. And then that correlation coefficient, did he miss it? No, he made it again.
That's the same one.
Man, that field goal.
Oh, no, it's a different one. Yeah.
Oh my
Another
goodness. That guy is drilling those field goals for the Cowboys. All right, so back to this. We're going to step forward in time. There's the circulation. Very, very impressive. Moving northeast and still cranking up. There's the velocity image. Long track tornado. Right on the leading edge. Nothing to choke it off. That's impressive right there, Zach.
Oh,
Big
wow.
time.
Yeah,
That
you don't
is
see those
big
colors.
time.
That was
No, you don't see those normalized rotation colors like that.
Yeah.
And so finally, that storm kind of goes out, still cranking, still a tornado.
It's like 80-mile-per-hour outbound winds.
My goodness. And
The
it's just still
oranges.
going. Now, you see those white outlines right there on Mega Doppler. White with red outlines is a strong tornado. So it's a considerable tornado. And then finally, I think you know what? That might, right there, I bet you it lifted just before Bowling Green. So I do think it did lift before Bowling Green. Okay, now let's take a look at the other tornado real quick. The Nashville tornado, because we're going to get close to the newscast. So here we go. Here's the Nashville tornado starting to touch down. Once again, another supercell on the leading edge of the line.
That also looked pretty messy right there.
I think there's a tornado in there.
But out ahead of it.
Well, let's look at the reflectivity. No, I think that's right smack dab where it needs to be.
Low
Now,
contamination.
all of this ahead of it is nothing. That is side lobe contamination and possibly non-uniform beam filling with the radar. So those are some things. Those are some signs. If you see this right down here, it looks like a strong circulation, right? Right. The wind is going we muted the whole time? Oh, why did it mute?
I don't know.
Yeah,
How long was it muted for?
I don't know. How long was it muted for? 10:31. That was weird that it muted.
Oh, just 2 minutes.
Okay. All right, guys. Well, I better get mic'd up here because we have a newscast coming up. But so, long story short, we can see those pieces of energy. Oh,
What happened?
I think everything freaked out on on this. Yeah, we can hear now, but we can't see.
Maybe stop and start the camera.
Yeah, let's try that. Go back to this. Let's see here. Camera background. I'm gonna have to do this. Let's try to see if we can start webcam properties. What? Deactivate, and let's try starting it up again. Activate. Better?
Yeah.
Okay, yeah. There we go. All right. So long story short, a couple things. I don't know why it muted all of a sudden. Sorry about that. That was weird.
Yeah, I don't
That
know.
just decided to unmute us. Maybe it was tired of hearing about the storms. So the bottom line is you can see the energy on the water vapor. You got to look for that.
Yep.
Systems have a long time to evolve before they move on shore. And so be cautious of forecasts 7 days out, especially 10 days out. There's a lot that can happen.
Things change.
Things change. Risks increase, risks decrease. They did not have a real high tornado risk on Friday for Nashville on Saturday. They did not have much of a severe weather threat for us on Friday. And really, honestly, that pretty much materialized because everything really didn't happen exactly the way that it was expected. But also, on the flip side of that, Nashville got a lot more than they expected.
Oh, yeah.
When they were looking at
Yep.
the storms Friday. Now, Saturday morning into the afternoon, things started ramping up, and they were realizing this is going to be trouble. So you can see the shortwave on water vapor. You can see the rising motion on infrared satellite, IR. It's a good idea to be cautious of those false trips on the velocity images.
Yeah, definitely.
Watch for side lobe contamination, non-uniform beam filling, and not only that, but got to make sure it's co-located with the reflectivity. Tilts are important. Looking at the times, if you're too close to the radar, you might not be able to see some of those low-level features. So, and of course, they're timing this all out with a bunch of storm spotters and stuff. Zach, you want to give them a quick rundown on the forecast?
Looking at pretty good.
Yeah.
Tonight, though, going to be a tad chilly. Those south winds picking up. So should be a wind chill factor tonight, mid-20s. But then the work week starts out nice and mild, 50s for those highs. Tuesday might even be in the 60s.
Yeah, let's check
So-
it out here. Bring up the graphics here. While I'm
Yeah.
getting mic'd up.
You can see it right there. See tonight,
Much time do you
mid-20s.
We still
And
waiting on the end of that.
with a breeze, going to feel a few degrees colder. But tomorrow, nice and sunny. The sun's going to be out. Those highs a few degrees above average. And then Tuesday morning, not as cold, still cold. And then beyond that, going to be in the 60s Tuesday. So looking nice. Wednesday looks quiet too. Thursday looking pretty decent. And then late week, another system potentially. And again, this system is far out, but we're going to have to be watching that one. But most of the week looks pretty quiet. So if you have plans tomorrow during the afternoon, should be a nice day for this time of year. Mid-50s, slightly breezy, but not
Is
too
that our
bad.
terminal?
And then Tuesday, the wind should die down Tuesday. So probably the best day of the week, if you ask me. It looks to be Tuesday. It should be the warmest. The wind pretty light, lots of sun. And then the winds stay pretty light Wednesday and Thursday.
And that's it.
Yeah.
Man, I do not know why it muted us. That was weird.
Yeah.
I'm looking here and I'm like, what was it muted? I thought I unmuted it.
It's working fine now.
Yeah. Good deal. It was probably tired of us talking about tornadoes.
Maybe we should shut it down.
Yeah, shut her down because I gotta open up a new show.
All right. Dan's about to be live on KNWA. So
Did you hit the
Go in.
gym today?
Yep, I did. Did some
Did
legs.
some legs, huh?
Yep.
Don't skip leg day.
Oh, can never skip leg day. Yep. Tomorrow we're doing some shoulders.
Nice.
Yep.
You know who didn't skip leg day? The kicker for the Cowboys.
Yeah, no kidding.
Yeah,
Man,
he is amazing.
What?
he doesn't
Yeah.
skip
Got
soccer
4 of them?
day either. Yeah.
You got 4 of them that game?
All right. Well, thanks
Well,
for
I
thanks for
wanna
tuning
see how
in,
far
and
he
Dan's
can
going to
get.
have the
I
full
think some of those
forecast
he
on the
can
news
percent.
tonight.
Well,
Thanks.
I was saying that